Once again, we've delved into the farthest reaches of the solar system to extract from the vast sea of knowledge a few gems that shine brighter than the rest, hoping to capture the attention of you thrill seekers. We present another 10 facts that showcase the incredible complexity of our cosmic backyard. Enjoy your viewing. If sound waves could travel through the vacuum of space, what would we hear? Let's be clear. Sound is a vibration in a physical medium, so it can't propagate in a vacuum. Indeed, in a vacuum, sounds don't transmit. Light, on the other hand, isn't considered a vibration of a material substance. Today, we know that all electromagnetic radiation, including light, can be interpreted as vibrations of the electromagnetic field or as extremely fast particles, photons, that are massless. Whichever scientific hypothesis you prefer, photons don't need matter to propagate. In fact, the presence of matter slows them down. The speed of light is highest in a vacuum, 300,000 kilometers per second, decreases slightly in the atmosphere, and drops to 200,000 kilometers per second when passing through glass. But if sound waves could travel through space, what would the consequences be for us? What would we hear? Well, the solar activity alone would be enough to overwhelm us. The sound, or rather the noise produced, would reach us with an intensity of over 100 decibels, like a car horn blaring right next to you, never stopping. Astronomers figured this out by recording acoustic pressure waves in the sun. These recordings result from careful monitoring of movements on the sun's surface, where every second releases energy equivalent to 1,000,000 billion hydrogen bombs. I'll add something to this. If you could hear the sun as described, and for some reason the sun suddenly disappeared, the light would last for 8 minutes, but we would still be able to hear the sound for over 13 years. This is simply because sound, at least in Earth's atmosphere, travels at a speed more than 1,000,000 times slower than the speed of light. Who deserves in the solar system the title of double planet? A natural satellite, in the most common use of the term, is a celestial body that orbits a larger celestial body, whether it's a planet, a dwarf planet, or an asteroid. In the solar system, 6 out of 8 planets, the only exceptions being Mercury and Venus, have a total of 288 satellites. 7 of the so-called dwarf planets, Orcus, Pluto, Haumea, Quaoar, Makemake, Gonggong, and Eris, have 12. Only Ceres and Sedna currently have none. And then there are about 500 tiny moons distributed among 447 asteroids. What changes in the 3 categories is generally the mass ratio between the primary and secondary bodies, a ratio that is very high in planets. A planet is usually thousands of times more massive than any satellite orbiting it and dozens of times larger in diameter. That's why the Earth-Moon system is a unique exception. With a diameter of 3,474 kilometers or 2,158 miles, the Moon's diameter is more than a quarter of Earth's, and its mass is about 1/80th of Earth's. No wonder the Earth-Moon system is often referred to as a double planet. To prove this point, consider that among planets, in terms of mass ratio, the second place, far behind, goes to the Ganymede-Jupiter system, with a ratio of 1 to 12,800. Quite a difference, right? But you know what? The crown of double planet would still rightfully belong, if Pluto were still considered a planet, to the Charon-Pluto system, where the mass ratio is an astonishing 1 to 8.6. A strange and controversial link between Venus and Earth. Until the 1960s, very little was known about Venus's rotation. It was impossible to achieve any results with telescopic observation. The thick atmosphere enveloping the planet hides any surface details and is so homogeneous that it offers no reference points. Only recently has radar technology allowed us to learn more. We have thus confirmed that Venus rotates on its axis in the opposite direction to all other major planets and dwarf planets, except Uranus and Pluto. A rotation that, in astronomical terms, is called retrograde. Early data indicating a period of about 244 days led to the hypothesis that in time between 2 successive conjunctions with Earth, about 584 days on average, Venus rotated exactly twice relative to Earth, always showing the same face to our planet at the moment of conjunction. But was it really so? A definitive answer could only come from improved measurements, and in the following years, further observational campaigns were undertaken, bringing the definitive rotation value to 243.026 days, slightly less than the theoretical value, 243.26, needed to ensure a true and stable rotation orbit resonance. The difference is minimal, but over time it would make the correspondence increasingly imprecise. But that's not all. There remains a curious numerical similarity, thanks to which the subtle game of orbital coincidences can be enriched with a new relationship. Yes, because of the time it takes Venus to rotate 3 times on its axis, 729 days, Earth completes 2 full revolutions around the Sun, 730 days. In other words, there seems to be a 3-to-2 ratio between Earth's orbital period and Venus's rotation. Is this also just a coincidence? The incredible Minuet of the Galilean moons. 400 years ago, the astronomer Galileo Galilei announced the discovery of 4 moons orbiting the planet Jupiter, each visible as a distinct white dot through his telescope. However, it is only in the last 4 decades that astronomers have been able to study Jupiter's moons in detail, revealing that Io, Europa, Ganymede, and Callisto are fascinating worlds in their own right. Although they are all similar in size, about a quarter of Earth's radius, the 4 moons are different. Io is violently volcanic, Europa is encrusted with ice, Ganymede has a magnetic field, and Callisto is dotted with ancient craters. Moreover, icy Europa is considered a strong candidate for hosting life in the solar system. But there's a question that still puzzles planetary scientists. Why are the orbits of Io, Europa, and Ganymede linked by an orbital resonance? Surprisingly, their orbital periods are in a 1-to-2, 2-to-4 ratio. Essentially, in the time it takes Ganymede to complete 1 orbit, Europa completes 2, and Io completes 4. Doesn't that sound incredible? Venturing a possible tidal mechanism, we might hypothesize that when the Galilean moons formed, they weren't in resonance with each other. All of them were in slightly smaller orbits than they are now. Over time, after their formation, Io's orbit slowly moved outward due to tides from Jupiter. This is the same effect that is causing our moon to slowly move away from Earth at a rate of 3.8 centimeters per year or 1.5 inches, the equatorial bulge of our planet. The same thing happens with Jupiter and Io, with a bulge in Jupiter's atmosphere causing Io's orbit to get bigger. As Io's orbit expanded, its year got longer, until it approached a 2-to-1 resonance with Europa. Once they reached resonance, they got locked in. Their mutual gravity acting on each other reinforced it. Io was still raising tides on Jupiter, though, and its orbit was still trying to expand. As Io's orbit kept expanding, it gave a gravitational kick to Europa on each pass, expanding both of their orbits until Ganymede reached a 2-to-1 resonance. The orbits are still expanding, but much more slowly because with each one you add on, it gets harder to transfer the energy. Callisto is too far away to join this dance, but it is thought that it could reach resonance within 1.5 billion years. Where does Pluto get the nitrogen it loses into space? Pluto is so small that it's hard to understand how its weak gravity manages to retain its atmosphere. We know that the dwarf planet constantly loses 50 kilograms per second of its atmosphere, which is almost entirely composed of nitrogen. Since the 2015 flyby of the New Horizons probe, scientists have been wondering why Pluto hasn't yet exhausted all its nitrogen. The best hypothesis is that some hidden geological process must be creating all the reserve nitrogen, but the exact nature of that process remains a mystery. Scientists currently estimate that the planet has about 30 billion tons of nitrogen atmosphere and loses about 1.5 million tons each year. Basically, it would take only a few thousand to tens of thousands of years to lose that atmosphere, which isn't a very long time. Considering that Pluto has been around for more than 4 billion years, the odds are pretty slim that humans would encounter the dwarf planet during its brief phase of having an atmosphere. No, something is replenishing the supply. There are two basic mechanisms for resupplying Pluto's atmosphere. You can either bring stuff in from the outside or bring stuff up from the inside. Comets are a handy mechanism for both categories, as they can deposit nitrogen when they impact or punch holes through the surface to expose quantities of the frozen gas. Scientists have crunched the numbers, but even with their most conservative estimates, the maximum number of comets, the deepest of impact craters, nothing from off-planet could cover the deficit of nitrogen loss. Instead, they suggest that the nitrogen is being replenished through more conventional geologic activity like cryovolcanism or tectonic action. But nobody yet knows what is behind this geologic churning, as Pluto's too small and too old to be holding much remnant energy from its formation. It's also too far from any planetary body that would be large enough to tidally churn its innards. Something else inside the dwarf planet is causing these exhalations. But what? Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. Sunsets on Mars would appear blue to human eyes. Mars is known as the red planet because the abundance of iron oxides on its surface gives the planet a reddish hue that is visible even from Earth. The Martian sky is also reddish, unlike Earth's, which is blue. However, during sunrise and sunset, the two colors switch. While sunsets on Earth are red, images from Martian rovers like Perseverance or Curiosity show that the color of sunrises and sunsets on Mars is distinctly blue. The reason lies in the fact that the atmosphere of Mars scatters light differently than Earth's atmosphere because it has much less gas and much more dust. On Mars, red light is scattered at greater angles compared to blue light. So, at sunset, when the sunlight passes through much thicker layers of atmosphere, the scattering of red light is even more pronounced, and consequently, only the sunlight with more bluish hues survives. Getting into the technical details, the scattering of light depends not so much on the chemical composition of the atmosphere as on the size of the particles causing the scattering. Earth's atmosphere is made up almost exclusively of small particles, mainly nitrogen and oxygen molecules, which are much smaller than the typical wavelengths of visible sunlight. In these situations, the scattering phenomena that predominates is Rayleigh scattering, which scatters blue light much more than red light. The atmosphere of Mars, on the other hand, is largely composed of much larger particles, namely suspended dust. There is little gas on Mars, as the atmospheric density is about 1/100th of Earth's, while dust is abundant due to the lower gravity of the red planet, about 1/3 of Earth's. When light is scattered by particles much larger than the wavelengths of the light itself, the dominant scattering mechanism is not Rayleigh scattering but Mie scattering, which on the contrary scatters red light more than blue light. At sunset, the light passes through more atmosphere. Therefore, on Mars, more Mie scattering occurs, and the red light is scattered to the point that a bluish halo forms around the solar disk, which Martian rovers have repeatedly captured. A small and wild moon. Sure, it's a matter of taste, but many agree with me that one of the strangest moons in the solar system is the misshapen Miranda, the smallest and innermost satellite of Uranus among the 5 major moons. Discovered by Gerard Kuiper on February 16, 1948, it was named after a heroine from Shakespeare's The Tempest. But while Shakespeare's Miranda is a young and beautiful woman, the moon Miranda looks like it was put together from pieces, like Frankenstein's monster. The small lumpy moon, 470 kilometers in diameter, shows a surface covered with skewed and interesting ice slabs, strangely rugged terrains, pockmarked plains, and dark irregular canyons. It's kind of like a badly crafted moon quilt, except there's nothing warm and fuzzy about a barren chunk of icy rock with grooves that make the Grand Canyon look like a paper cut. How the small moon became this way is still a mystery. One theory suggests that shortly after its formation, Miranda was just a smooth ball of ice until one or more impacts shattered it. Eventually, the pieces came back together, but not in a way that made much sense. Another hypothesis suggests that meteorite impacts locally melted the moon, and slush rising to the surface form the giant, rigid patches scientists called coronae. Other theories have thrown in a little icy volcanism and internal heating caused by gravitational interactions with Uranus and its other moons. Or Miranda could have begun to differentiate, with its internal layers separating into something like a core, mantle, and crust, but froze before it finished the job. At the moment, it's hard to say more, and while we wait to solve the mystery, we have to make do with the only images we have, taken by the Voyager 2 probe that flew by on January 24, 1986. Venus shouldn't, but it always shows ashen light, like the moon. You're all familiar with that evocative phenomena where, when our moon appears as a thin crescent, the shadowed part of the disk is faintly illuminated, revealing the most prominent surface features. In this case, we know that the cause is the light reflected from our planet. Essentially, in the lunar region affected by the phenomena, any lunar inhabitants could enjoy a romantic Earth shine. The surprising thing is that the same thing seems to happen on Venus, where the ashen light appears as a faint greenish, grayish, or reddish glow affecting, in whole or in part, the unlit hemisphere of the planet. The first report of the phenomena dates back to 1643 by Giovanni Riccioli, and since then, many astronomers, including the great William Herschel, have reported its presence, particularly around inferior conjunction or when the planet appears as a thin crescent. Given that the visible emission exists and seems to be confirmed, what could be its cause? So far, the only visible light emission definitively detected in the shadowed hemisphere is caused by the recombination of oxygen atoms in the atmosphere, known as air glow. Carbon monoxide, CO, molecules in the upper atmosphere are disassociated by ultraviolet sunlight when on the illuminated side. The oxygen atoms, carried by the violent winds blowing at about 60 to 70 kilometers altitude, move to the shadowed hemisphere and recombine into molecules, emitting a faint green light. On Earth, a similar phenomenon occurs and accounts for much of the natural brightness of the night sky away from artificial light pollution sources. Could the observed emission be caused by this mechanism? It seems unlikely, as the intensities involved are very different. It's true that the emission intensity on Venus is much higher than on Earth, and marked peaks have been observed, but all measurements show brightness levels much lower than those reported by observers. Could it be that for some reason the emission becomes much stronger at times? This would explain why the ashen light seems to vary in intensity and isn't always observable. But this possibility, although based on a known and studied mechanism, doesn't seem very plausible. Another explanation, perhaps even more controversial because it is based on data still under thorough investigation, considers the presence of lightning in Venus's turbulent atmosphere. Early probes such as the Russian Venetia and the American Pioneer detected electrical activity associated with lightning, but optical images were contradictory, and only in one case was there evidence of flashes caused by them. In 1998-1999, instruments on the Cassini probe during its flyby of the planet did not confirm this activity. In 2007, the arrival of the European Venus Express probe and new studies definitively confirmed the presence of lightning in the planet's atmosphere at an altitude of about 50 to 60 kilometers. These are generally more intense electrical discharges than those on Earth, occurring between large clouds of sulfuric acid and not discharging to the ground. Their intensity, about 100 events per second, seems compatible and could justify the slight luminescence observed in the unlit hemisphere. This second hypothesis currently seems the most consistent with the observed visible emission, but the true smoking gun, a consistent observation over time by multiple observers, has yet to be found. The mystery continues. Remember the story of Venetia, the girl who named Pluto? As you probably know, Pluto was discovered on February 18, 1930, but the Lowell Observatory Committee waited until March 13th to make the official announcement on Percival Lowell's birthday. Meanwhile, as noted in the memoir of the discoverer Clyde Tombaugh, the task was to decide on a name, and the choice fell on Pluto, a name suggested in the telegram sent on March 15th by the 11-year-old English girl Venetia Burney. The The proposed name was accepted because it fit well mythologically with the distant and dark regions of the solar system where the planet moved. Pluto in Roman mythology is the god of darkness and the underworld. And because the first two letters, PL, recall the initials of Percival Lowell, and some say the ending TO for Tomba. Perhaps not everyone knows, however, that this girl was the great niece of Henry Madun, who in 1878 suggested to Hale the names Phobos and Deimos for the moons of Mars just discovered by Asaph Hall. Just a coincidence? Well, in the archives of the Flagstaff Observatory, hundreds of letters have recently been found, sent from all over the world for the same reason, to propose a name for the latest addition to the solar system. A flood of strange, appropriate, unsuitable, imaginative, and incredible names ended up on the desk of Vesto Slifer, director of the Lowell Observatory. Splendor, Kronos, Pax, Ariel, Salacia, Athenia, Nuevo, Utopia, Maximum, Persephone, Erebus, Atlas, Tantalus, Prometheus, Perseus. And these are just the more sensible proposals. But some people had no problem supporting, for example, the candidacy of Tuello, from the combination of the first three letters of 20th century with the first three of Lowell, or Burdett, from the name of the town where Tomba came from, or Rima, from Rim, because the planet is at the edge of the solar system. But there's more. Unexpectedly browsing the archive, it turns out that the name that appears most frequently in the proposals is precisely the one chosen by the 11-year-old Venetia, Pluto. One example is the letter from Ruth Van Sickle, also a young girl at the time, as we have reconstructed by looking online. She was born in 1916 and would die in 2009, a few months after Venetia, who wrote to the observatory on March 17, 1930. I read in the newspaper about your discovery, and for the new planet, I would like to suggest the name Pluto. A choice I made because I think this new planet is as important as Jupiter and Saturn, and therefore deserves to bear the name Pluto, their brother. It is indeed a bit surprising if so many people suggested the name Pluto. Why emphasize Venetia's choice with such media attention, as if she were the only one? Why not reward, for example, an American girl like young Ruth? It's hard to reconstruct the story after so many years, but it seems that the final decision was up to the director of the Flagstaff Observatory, Vesto Slifer, who was likely not insensitive to the fact that Venetia was the great-niece of Harry Madan, an influential English chemist who, more than 50 years earlier, had named Phobos and Deimos the Martian satellites. That's how the world works, folks. Friends of friends. You know how it is. The solar system is over 4 light-years wide, or 250,000 times the Earth-Sun distance. It is well known our solar system is full of planets, asteroids, comets, dwarf planets, and trillions of other small objects, all orbiting a medium-sized star we call the Sun. But incredibly, all this is just the innermost part of the actual solar system, a region that probably extends only about 1,000th of the entire system. Thanks to the Voyager probes, we can say we've detected, beyond the Kuiper Belt, which extends up to 50 to 60 AU, the existence of the so-called termination shock at about 80 to 200 AU. This is the point where the Sun's solar wind, traveling outward at 400 kilometers per second, collides with the interstellar medium, the background material of the galaxy. This material, shaped by the interstellar wind, takes on the characteristic teardrop shape of the so-called proplids, short for protoplanetary disks, and it is in this form that we would see our solar system if we could observe it from the outside. But the true size of the solar system is defined by the reach of its gravity, that is, how far an object still feels the gravitational pull of the Sun. In the most remote regions of the solar system lies the Oort cloud, a theorized cloud of icy objects that could orbit the Sun up to a distance of 100,000 astronomical units, or 1.87 light-years away. Although we can't directly see the Oort cloud, it is thought that long-period comets that occasionally fall into the inner solar system come from this region. So we can certainly say that the sphere of influence of the Sun even interferes with that of our neighbor Alpha Centauri, just over 4 light-years away. It is now being accepted that there is a continuous exchange of objects and matter between the two stars, as hypothesized for the mysterious object Oumuamua, possibly of Centaurian origin. And these hypotheses, needless to say, open up intriguing scenarios about the possibility that life could also travel easily from one star to another.